All right. I still don't know. I guess I could look at yesterday's video and see if, or the previous video from earlier this evening, and see if it has the same issue. Because like the process that I used for starting streams rather, for the previous days, like didn't work yesterday, and it didn't seem like it worked today either. And I don't know if it's because I created the broadcast like right before I went live or what, but it was like 10 minutes before. I don't know. Kind of weird. Anyway, I'm pretty sure we're streaming now. So I'm going to do day 13 here. Actually, I'm going to first look at this and see what this drawing is. Kind of interesting little structure there, isn't it? Huh, I don't know. Okay, I've decided I don't care after all. So I did read day 13 off camera to see like what was going on. I have some ideas. Day 13, transparent origami. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you are greeted with, "Congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual." You find the manual and you open it, page 1 falls out. It's a large sheet of transparent paper, marked with random dots, and includes instructions on how to fold it up. So the dots are indicated like so, and there's folds. The first section is a list of dots on the transparent paper. 00 represents the top left coordinate. I don't think that actually matters to us, by the way. We do need... I guess we do need to. Yeah. I think we actually need to use the same coordinate system they're using today. Because there's... In addition to this stuff, there's these, and those two kind of have to agree. Okay, the first value, x, goes up to increases to the right, the second increases downward. Yeah, okay, so top left is 0, 0, etc. They said that already. And the coordinates are places that are marked with dots. Here's an example, or in this case with hashes, really. There's a list of fold instructions. So horizontal lines where y is a constant, or vertical lines where x is a constant. And when you fold them, the paper being transparent, if there's a spot that's not marked, say here, this spot corresponds to that spot, right, across this horizontal fold. This space will end up being marked because there's a dot in at least one of them. The paper has been made opaque in this place by the presence of at least one dot. And somewhere, yeah, like for example here, these two dots are opposite each other, so when you fold them together, it's still just a dot. But most places, there's no dot at all. Like this here corresponds to this square, and after you fold it, the paper is still transparent. The two dots in the bottom left corner before the paper is folded, they're talking about these two. These two. After the fold, they appear up here, of course, as these two. Dots can overlap, and then they're just like one dot. So the fold, yeah, okay, so you fold it like that, and oh, look at that, it turned into a square. And they say for now, focus on just completing the first fold. And then 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. I'm not going to take their advice. I'm going to focus on doing all the folds, because it seems like once you've solved one, you've pretty much solved them all. So let's get working on this. Or actually, let's get my input, which, you know, has a large number of dots and a small number of folds, as you might expect. I'll just put this in input.txt without you guys needing to bother watching. Really, nothing interesting is happening. Okay, so I want to talk a little bit before we get going about the thoughts that I had after reading this, but before starting the video. My first thought was, why are they telling me fold along y equals 7? because there's uniquely one way to fold the paper in half, was my thought at first, right? If you folded the paper anywhere but here, it would be asymmetrical. The top would be larger than the bottom, or vice versa. And so I thought we might just reduce the input to like fold horizontally, and then we would have like, you know, some data type that represents this grid, and we'd have like a fold horizontally function that turns it into two smaller grids, flips one of them, and then overlays them on top of each other. This turns out to not be a correct way to think about things, because you aren't given the bounds of the paper. Right? Here, for example, suppose we had this shape. We don't know whether, like, this is the middle, because there's 3 above and 3 below, or, like, this is the middle, because there's 2 above and 2 below, and, like, these are all empty, which is kind of the same as not being specified at all as dots. If they gave us a grid and told us where the dots are, yes, then we could just ignore their dimension instructions. But since they're only telling us where points are, we can't determine where the edge of the kind of conceptual grid is. So we do care about the coordinates they're giving us to fold along, not just the direction, because it helps us find the center of the paper. Now, in this example, of course, neither of those can be the center, because the puzzle promises there'll never be a dot along a fold line, so you couldn't make this a line. And it's so hard to highlight stuff, and you couldn't make this a line either. But if these were all dots, and there was just like one hash here, we couldn't tell the difference. So my second thought was about what data types to use to represent these dots and this grid and so on. And my first thought was, well, we could have like an array that is filled with some constant type, have a non-sparse array, two-dimensional grid, where we put in something. Putting in dots and hashes, I think, would be foolish. But there are some types that are useful for combining, because every time we fold the graph, we kind of want to take the two characters that are at the corresponding positions on the top and bottom half of the fold and combine them in some way. Is there a good example of this around here? All right, here, for example. So if when we fold these two, we're combining this character and this character. We're combining this character and this character. And this character and this character, for example, are both hashes. So you have to have a way to combine hashes, a way to combine dots, and a way to combine one of each. And when you talk about combining things of the same type, the first thing you should think of is like monoids and semigroups. Is there some way to view that combination as either a monoid or a semigroup of some kind? And I thought of two perfectly reasonable monoid and semigroup types that would make sense for us to combine in this way. You could represent this as maybe unit. That was the first one I thought of. So let's talk about that a bit. So in particular, like, you know, if we said, you know, maybe unit is a type with exactly two values in it. Nothing as a maybe unit, that's a valid value, and just unit, that's also a maybe unit. And that's really only two you can construct, and it already has the right monoid instance, right? You can say nothing plus yeah, we're going to get to, I think, the right representation for this problem. We're talking about what I thought of at first. So combining nothing with a dot, you get a dot. They're kind of overlaid on top of each other, right? And likewise, if you flip them, you still get a dot. If you combine nothing with nothing as a maybe unit, you get nothing. And if you have two just combined with each other, oops, you get a just unit. So that is an existing type with a useful monoidal structure for us to combine overlapping points. That was the first thing I thought of. And then I was like, are there any others? Well, yeah, it's kind of like a bool we're talking about, right? You have bools with or. If A is a dot or B is a dot, then the result of combining A and B is a dot. And so we could import, for example, data monoid any. And then if we say any true combined with any true, we get any true. If we say any false combined with any false, we get false. And if either one of them is true, we get a true, right? This is another type where we could kind of take two values of the same type, overlay them on top of each other with mappend, and get the effect of like them being overlaid on each other as opacity on a transparent background. And that's like kind of interesting. But as I say, this is not actually the right way to do this problem, I think, because there's no point reifying like the actual grid and filling it with a bunch of objects saying there's nothing here versus there's something here. It's actually, I suspect, quite a bit simpler to use a set, where you just have a set of coordinates. And when you're asked to fold, and any coordinates that are not in the set are sort of implicitly not dots. The ones that are dots. And when you're asked to fold the paper, you partition the set into two halves based on what's above and below or left and right of the fold line. And you do a transform, a mirroring, basically, of one of the sets on top of the other. And then you just like union the sets. And that way, if there are two if the coordinates there twice, one of them gets dropped and it still ends up being there. And if it's there once, you get to keep it, and if it's there 0 times, it's still empty. So I think that is the right way to do this. But I still think it's useful to think about these other ideas of I guess what I'm getting at is the concept of a set is kind of a more abstract representation of the problem space. You say, oh, there are some dots, here they are. And then you have ways to transform where the dots are. And that's fine. More abstract is often nice. There are sometimes cases where you might be better served by a more concrete representation because you realize there's some hole in the abstraction that you've used, and it would be easier to work at a more concrete level. I don't think this is one of those cases, because what they're going to ask us is pretty straightforward. But there's tons of times where you, like, I don't know. I've in the past, like, Dominion is a card game that I haven't played in a while, but I played a lot of several years ago. Where on earth can this be going, you ask? And when you try to write like a Dominion engine or simulation or whatever in any language, but I wrote a page or two of doing one in Haskell and then gave up sometime in the past, and I saw some people who were more experienced at Haskell doing it as well, and some of them got quite far and wrote a lot of stuff, and it turned out to be just like absolute junk because they didn't really understand what was going on, and they had built a bad abstraction over the kind of more concrete notion of there are cards on the table and like you move cards from one place to another and then something happens. They had, these abstractions like, okay, well, when you play a card, some stuff happens, and you make a decision about what card to play or whatever. But it got really tricky to have like, oh, when does a card appear in your discard pile? When you're done playing it, of course. Oh, but sometimes you play a card, you execute a card's effects without ever actually playing a copy of the card because, like, you you play a card that tells you to play another card twice, and like it gets tricky. You accidentally wind up with 2 copies of the second card if you kind of thought that playing a card makes it appear in your discard pile. And if you had worked at a more concrete level where you were managing like areas of the table and physical cards and where they should be, you would have realized there was this kind of distinction between performing the effects written on a card and moving a card from one place to another, that those are separate actions. And so my point is just like, sometimes if you pick the most abstract level that kind of makes sense, you'll realize there was some hole, and the next thing you try to do will fall apart. And so I kind of like starting from a more concrete representation, and then, you know, turns out that, okay, a more abstract thing of sets is actually right, but it's still useful to be able to think about these concrete things because they have fewer holes between you and the actual domain. That's all there is to say about that, right? The input kind of suggests, or the problem description suggests a grid, right, with dots on it in particular places. And a more concrete representation would be an actual grid with indicators on it. Here's a dot, here's not a dot. But okay, enough going on about that. In this case, we will, I think, use a set of coordinate pairs, and it should be fine. So, what do we have to do? First, let's, I guess, find a new type coord, which I think can be concrete. I don't see any reason it needs a type parameter. Coord of... Why exactly am I doing it as a new type instead of a data with 2 fields? I think that's a pretty dumb idea. Data coord equals coord of x, y, which are both of type int. Yeah, if part 2 were something completely unexpected, there might be a problem, but it seems extremely likely they're going to ask us to fold the whole paper together, yeah. But just, you know, thinking about, okay, we have this abstraction of a set where we can kind of ignore the places that don't have points. Is this going to get in our way for what we expect the problem to be? I think it's not, so it's a fine abstraction to use, and it'll be fairly simple. So our well, okay, we need more data types, right? Data, let's say fold, is a fold of orientation and... Is that a good idea? Should it be an orientation? I guess. Well, maybe axis. And an int, I guess. And we'll say that data axis equals x or y. We'll probably want to give these show instances at some point, but for now I don't seem to need them. And so my input is, I think, going to just be an actual data type, not an alias for an existing type. My input is an input containing, first, a... Oh, we need ecoord for this, at least. We're going to be putting them into a set. Is it going to be a set of points or a list of... Well, wait, why am I calling this coord? It's a point, obviously. Well, I just typed the wrong point. There you go. Is it going to be a set of points, or are we going to put in a list of points? I don't see any reason to use a list, so let's use a set of points. Import qualified data set as S. And then also a list of fold, right? We could make it a non-empty list of fold, but I don't want to go down that rabbit hole again. And let's take import text regex applicative again. You know, one of these days I'll realize that I should just use parsec for everything, and what's the point of using this weaker tool, which gives you worse error messages. But for now, I still like it. So we need regexes for these things, right? For a point, and for a fold, and I think that's about it, right? So point is a regex of point. We have to first define type regex a is an rechar of a. Okay. Point is, oh, I guess I will today need digits here, or decimal. Yeah. Point. Yeah, you would think less flexibility means less things to mess up, but I mess it up a lot with regexes. And the only feedback that I really get is like, oh, I got nothing as a result. Great. What was wrong? Whereas parsec will tell you on line 5, character 9, I expected an open brace, but I got a 7 or whatever, right? So because a regex is non-deterministic, it can go multiple directions at the same time. It can't really tell you what it was expecting. I think it can say what, you know, I was expecting one of these 5 things, maybe, but I don't think it does say that. Anyway, so point, though, is still fairly simple, right? It is a point of, what am I doing? A decimal and a comma, right? Commas, yes. And then another decimal, very easy. Sure. And let's actually say, furthermore, that it is followed by a new line. We'll just handle this all in the regex. Great. Now we have a parser for fold. Fold is fold. I have a fold type, right? Yes. Fold of string fold along axis sim equals we'll ignore, and then a decimal where axis is y of sim y or x of sim x, right? I don't know how to align that, maybe like that. Does this compile? Well, it won't because I don't have my input type right, but does everything else look okay? Okay, so far, I mean, it's upset that our inputs don't match, but everything else looks okay. Let's just say it's undefined. Everything compiles. Great. So, if we were to say, oh, we haven't written our input parser yet. Prepare is Well, what are you supposed to do if everything fails, right? I guess we can say... there's still more stuff to do, I guess. Let's just do it like this. Prepare is from maybe of input empty. There you go. So if you fail to parse, just put in 0 things. Of dot equal tilde input, where input is an input parser over dots, and then I think we need one extra new line in here somewhere because each dot ends with one new line, but our input has an empty line in between them. Dots, folds. And are we going to say that each fold ends with a new line? I guess we forgot to do that, didn't we? There you go. And dots is s dot from list over many point. From maybe is not in scope. Again, import data maybe from maybe. There must be some way to get it to apply. If I, all right, let me try this real quick. If I delete this, yeah, see, like it gets stuck. It doesn't know. I still don't know what I'm supposed to do to get HLS to understand that these exist. So far, only interactive Haskell mode knows about them, and it makes my whole file a mess. Okay, anyway. So, we can say, test this in the REPL a bit, right? I'm in the wrong day there. And we can say prepare of 110, new line, fold along x equals 5, new line. Yeah, no way to parse that. I don't really want to add a show instance to everything just to do that. Case of nothing, who, just x's. Oh, wait a minute. It's never nothing. Because we already converted it using, we defaulted it if it didn't parse. So I guess we could say input x's or puts ifs. Puts ifs. That won't work. Length points, length folds. That should tell me, did we get one of each? We did. Okay, so that all parses just fine. Great. So I'm prepared to believe our parser is correct. So I think the kind of core operation that we have well, the operation that we have is fold, and I've already defined a function named fold, haven't I? Let's just dump all this into the where clause for prepare. Fold, axis, point, it's amazing. There you go. And I don't even need that type alias now, because I never declare a regex. Okay, so that still works, right? Yeah. All right, so now I think the kind of core operation we have is a function that takes that's a fold. It takes a type paper equal s set point. It takes a, I don't know what order I want to take the parameters in. I don't think it matters very much. It takes a fold and a paper, and it gives you back a paper. So basically what we need is a way to transform each point around a fold. Half of the points in the set will stay the same, and half will be changed, be mirrored around an axis. Well, not half, we don't know. Half of the points in the coordinate system will be flipped, but the number of non-empty points that will be flipped is unknown. Could be all of them, could be none, could be anywhere in between. So we are promised that nothing will exist on the axis, so we don't have to worry about that. So I think though it's fairly, like, there's no point really in trying to modify the input paper, like by taking out the points that shouldn't be there and adding in new points that should. I think we can basically just transform the elements and then build a new set out of the result, and it should be about as efficient anyway, right? So fold FP is s.fromList of map transform P. P is a set, though. We don't want to call map on a set. So if we look at data set, there's map, and there is a function called map here, but that's not what I want. I just want its elements, right? And I think the function I want is elements, basically. Wait a minute, what is... Oh, you can actually just do that, huh? You can map a set, and you might get a smaller set back. Okay. An A to B and a set of B? If for some xy that are different, they map to the same thing. Oh, this is great. Okay. Well, forget my dumb idea of using map. It'll be s.map, and in fact, I can just forget this stupid p. Transform, I guess. I'll just have the f in scope, where transform what do you call this? The distance? The intercept? Okay. I'm sure there's a word for it. I don't know. I think it makes more sense actually to do the case match in here. Crease? Yeah, maybe. I was thinking of it in terms of a graph, not in terms of a paper. Transform of fold x and point xy if xi, let's say. So if the x is less than I, is just p, right? You leave the point alone because it's already on the low side. Otherwise, it's greater than p, and so we have to it's point of x minus p. X is greater than x minus I, and then y. And transform of fold yi is kind of going to look the same as this. I need to go take a quick break. You guys can mull over this fold function for a while if you like. One of the many things that I like about doing recordings instead of streams is that I can just cut those breaks out and I don't have to feel like I'm leaving people waiting here or that I have to rush to get back. You asked, does x minus I mirror it? I think it should, right? Like, if you're folding along like x equals 10, right? And you have 12. Oh, that doesn't work at all. X minus I. That doesn't work because x would be 12, you'd be subtracting 10, you'd get 2. And that's not right. You want 8. Yeah, so there's got to be some negation here, right? We have to compute the difference between our point and the crease, which we've done. It's x minus I. But then we need to subtract that from I. So it ends up looking like I minus x minus I, which seems very weird. This doesn't seem right to me. But let's just do the math on this. It ends up being I minus x. That should be negative, right? How is coordinate math hard? There's a comment in the chat that has the formula, but I'm not going to take this at face value. I'm going to think about how it comes out, or try to come up with it myself, because it shouldn't be hard. We're on the right side of the fold in the case of y well, I guess in the case that you fold. Wait a minute, am I crazy? Okay, first of all, I have the x and y axes mixed up. Oh yeah, I did, right, because the i's don't cancel, they add up. Yeah. Okay, so mine is right here. I minus x minus I comes to 2i minus x, which is fine. Except that I've got x and y axes mixed up, because x... Oh wait, maybe it is right. So for folding along the across the line, x equals 5. What is x equals 5 exactly? It is a vertical line. And so we'll be looking at a constant... We'll be ignoring the y coordinates and transforming the x coordinates. So actually, yeah, this does seem right. I thought it was backward. So this... I actually kind of like this, as opposed to the 2i minus x. Because it makes it clearer to me what's happening. You're computing the difference, the distance from the fold line, and then subtracting that distance. I minus y minus I. Okay. So does this like compile at all? It does. So suppose, oh, who cares? Suppose that we said I want to fold along x equals 5, as I was doing in... Well, let's grab an example from the puzzle, shall we? Fold along x equals 5. That's one of their examples. Great. Oh, but they're doing it... All right, we'll fold along y equals 7 first. Oh. Oh, I just realized that can be fancy. This is not anything like algorithmically clever, just kind of taking advantage of Haskell's syntax language to make things look a bit nicer. but we'll get to that in a moment. I want to test this first. So folding along y equals 7, let's take this point 6, 10, that is their very first example. Point 6, 10. Oh, I haven't reloaded. Oh, still wrong. What is... I thought my function was called fold? Oh, I can't... Okay. It takes an entire paper. But I can't show it. Yeah, kind of annoying. Alright, whatever. We could define transform... Hey, Rubix, you made it this time. To actually... me not being done yet, you know. No blame on your end. I just announced these with fairly short notice, and you got here at a bad time last time, it looks like. I would like to test this. I guess I'll just put show on everything. I kind of hate it. I guess I only need it on point, right? Yeah, so along y equals 7, y was 10, so it was 3 away. Now it's 3 away in the other direction. This seems good. Okay, cool. So, I remarked just a moment ago that I can be a bit more clever, I think. And I would just like to rename the fold constructor, and we'll just call it equals. And now you can fold along y equals 5. It'll be great, right? There you go. Ooh. Data constructor not in scope. Yes, okay, so we'll just call this, there you go, equals. And this will still, I believe, work, except that I will have to change this to be equals. So fold along y equals 7, and we get this nice little point. I like that just because it's a slightly more... It matches better what you would like to say out loud. Okay. Cool. So, I think we're ready to write part 1, basically. I've parsed the input. I have this function that is basically like what to do with the input. So part 1 of input... What is this, by the way? It wants an int. Input, which is a paper, P and F, and then all the rest of the folds is s.length of fold F P. Did not set the, oh, is it size? Okay. So let's just try running it and see what happens. Stack run, not rung, thank you. And we get 647. So that was what they wanted. How many points are visible? Yes, okay. So let's see what you think of my input. 647. That's the right answer. Okay. Okay, yeah. This, I wondered if this might be... There was one a year or two ago where it was this way to describe some text or a picture, and you had to like look at the picture with your eyes to understand what was happening. And I was using a different coordinate system, so mine came out upside down or something, but it was still legible. So we need a way to draw a paper, which is like, if only we were using an array, right? what actually, like, how do we find the bounds that we want to draw in and then shift everything according to that, basically? I guess we don't really have to. We know there's 0, 0, and we can find the... I kind of do need the max x and max y, right? Just implement show for paper. That's illegal. I can't. Also, it would be hard. It would be not so hard to make it legal, but right now it is illegal. Because paper isn't a real type. It's just an alias for the existing type set of int, which is already showable. I could make it a new type, and that would be fine. Yeah, if I kept any utilities from day to day, I'm sure I could find one of these from a previous year where I had done this before. But it's sort of a nice, reminder every year to... Oh, that's a good point, Michael. I know the dimension of the last fold's x and y, or I could know them anyway, which would tell me the dimensions of the paper. It should be like exactly equal to the last y and the last x, I think, right? If it folded along, let's look at the diagram. If it folded along x equals 5 here, 0, 1, 2, 3, 4, 5, then we know that the maximum x is 1 less than 5. You do always fold the paper in half, Jonathan. The problem would be ill-defined if you didn't. We talked about that, I think, before we started implementing anything. It doesn't make sense to do a fold that's not in half. So it's not... There's not a pretty way to remember what the last x and y folds are, really? I mean, I guess as long as we're willing to read the input list 3 times, which is fine, I guess. We're already reading it twice to do part 1 and part 2. It's not so bad to get x and y out. Yeah, that's not bad. Okay. So part 1 of input p... Oh, hang on. Let's commit it. We always got to commit it. Git add dot git commit day 13 part 1. Input p f's. This returns an int. If you fold from the line 1 from the bottom, you mean 1 below the bottom or 1 above the bottom? It doesn't matter. Because anything that's below the fold line, we can ignore now. Right? We can just say whatever was above the fold line, those were the interesting points. We don't have to know how big the paper is. I guess we'll just let... Oh my gosh, this is so much cheating. We're going to just call head on a list and it might return... It might break, but of course it won't. Let y equals head of y for y and y in f's. We have non-perfect folds and have it still turn out. X is head of x for x f's. And I guess we'll have our new paper be this is a fold L, right? I don't think there's any reason to do something other than fold L here. Import data list fold L prime. Rubik's did it with no folds, as I recall, huh? You didn't even do a fold here? You did the manual recursion or something more clever that I'm missing? Ugh. Flip fold. I gave fold the wrong parameter order, as it turns out, because this is a fold L. Okay. P Fs. Take a single fold and the existing paper and we modify it. Yeah, okay, that looks right. In? What am I doing now? I guess it's not really an int. It's I guess it can just return a string. I don't think I said he. I remembered you're a woman. Did I say he? I apologize if I did. You mentioned it in a previous stream. And I try not to use genders for people unless I actually know what they are. I thought I said Rubik said you did it. If I said he, I apologize. Anyway. So we have the x and the y. So we can basically just iterate from x to y. All right, let's just do a do here. There you go. In do. Okay, and now it goes to the left. Haskell's indentation rules are somewhat arcane, but I guess this is allowed. And it makes sense. It makes sense. I know. So. We'll call this max y and max x. X for uh, 0 to x, y. Oh, hang on. I don't want to loop over them both. I want to do something. So now it's I want to make a list of lists, or a list of strings, kind of, right? There's like, I haven't done, I don't use this stuff in data list to like intercalate and whatever. I'm supposed to like, I want to like join on new line, and that's like, oh, but it's not called join in Haskell. We call it intercalate or intersperse or something. So for each x, I'm returning pure of. No, this can't be right. Not if I'm returning a list of string. Well, I guess I sort of am. Pure of no. Oh my god. Intersperse new lines between do, and then I can return a list of rows. I need to import intersperse from here. EFGHI intersperse. Lines and unlines I can remember. Intersperse and intercalate, I know what they do, but like it's just less natural than using join, because I've been doing that for years and years and years. So we have, okay, now for each x we want to return a single line. Now we can say pure of do y 0, oh, this shouldn't be x, max x, 0 to max y. Oh, but these are y first, iterate y first, okay. Pure of if s member p prime xy, then hash else dot. Does this compile at all? Of course not. If what I wrote is garbage somehow. Intersperse new line of do. All right, GHCI, would you please explain to me what the hell this HLS person is saying? Oh, intersperse is wrong here. I do want intercalate. I know what they do, but I need to flip the order. Oh, S member is also backwards. You're right. That's not the only issue. Is it? I don't think so. And it's not a pair, it's a, okay. Point xy. So that's wrong as well. And now the problem is we actually do need intercalate like that. Okay, that compiles. Are you kidding me? I thought it would fit on a line. Okay. It's also way too big? Am I crazy? I did something wrong here. Jonathan says it should. It should what? I assume it would fit on the screen. Let's Oh, did I write head? Oh my god, thank you. Last. Good catch. Thank you, Rubix. That was gonna take me a while to find, I suspect. This looks like I could almost read it if it were printed properly. Okay. Well, so much for producing it as a tuple. We'll change our main for now. Do input is this. I could just do this every day, like print part 1 of input. Oh, prepare of that. Print part 2 of input. Right, like this also compiles. Does it run? I mean, it should. Is it going to print anything good? We'll see. Oh, but I don't want print. I want put stir for that one. That's the whole point. Okay, those are letters. We did it. HEJHJRCJ. Goodness, those are letters. Let me just type that in by hand as HEJH, I think? Yeah, JRCJ. Okay, so that's day 13. I still haven't done part 2 of day 8 or day 9. Maybe I'll get to those one day, but I'm not very excited about them. Sure, get status here. Not very interesting, I guess. Git add p. Anything cool going on? No, not really. Git commit-m day 13 part 2. Michael says, interesting that we get different inputs since my letters were different than yours. Yeah, I mean, everyone gets different inputs, right? So you can't, for every problem. They don't have, millions of unique inputs for the millions of players or however many there are, but there's enough unique inputs and answers that you're not generally going to run into people who have the same input as you do, I think, is the idea. We can push this. You have no idea what the ASCII art is going to be. The ASCII art, oh, on the calendar, I see. This bit almost looks like, I don't know, legs? A little scuba diver? I don't know what we did on day 5, though. Hydrothermal. Oh, that's a vent. It's a hydrothermal vent. See, right there? That's my opinion. Bubbles coming out of it. Yeah, I mean, it looks like kind of a map of the ocean that we're getting into somehow or other. But I'm sure there'll be some cool stuff in it somewhere. Some jellyfish, maybe? I don't see any jellyfish yet. But in the animated one that comes at the end, maybe there'll be flashing jellyfish. That would be appropriate, I think. So has everyone in the chat done all 13 days? Am I the only idiot? Or are you guys skipping some that you don't like as well? There have come years. There have been, I think, only one year where I did every puzzle the very first year. Last year I skipped part 2 of one puzzle. Yeah, the right hand. This looks like the cave when we broke into the cave. What's these colons like when we pierced the veil here? When we burrowed in. When were the crabs? Those were like day 7, right? Yeah. I thought maybe this would be the crabs punching a hole in the cave, but it doesn't seem like it. Okay, well, I think I'm gonna get out of here and head to bed and stuff. Thanks everyone for coming. It's been a busier chat than usual recently, or today. I think has been busier than usual. Maybe be no, I guessed right. Crabs were 7. 6 was lanternfish. More lights. Lanternfish. That was a good one. I think. I mean, day 9 doesn't look that hard, but I'm just like, the number of times that I want to implement another coordinate system and do searches through it is not that high anymore. I'm tired of that kind of problem. That we haven't had any this year, but I don't know. There are previous years. I'm just not excited about grinding through that. Maybe if I kept helpers in between years like Rubik's, I would be in better shape. Okay. Well, as I was saying, thanks for coming, everyone. I'm gonna shut the stream off in a couple minutes. You have that time to chat with each other and say goodbye or whatever. And I'll probably see you tomorrow night. I don't think I have anything coming up. I should actually get to bed tomorrow night. I have a thing that I have to be up for in the morning, so maybe I won't do Monday until Tuesday. We'll see. Tuesday I shouldn't be busy though. Okay, anyway. So I'll put put up stream notifications when I know I'm going to do it, which might be a day ahead of time, or it might be like 5 minutes ahead of time. Thanks for watching, and I will see you next time.